Welcome to the deep dive. If you look around right now, um, the biggest tech companies in the world are spending, well, literally billions of dollars trying to build the ultimate AI coding agent.
Oh, absolutely. Billions.
Yeah, and we're talking about these massive feature-packed platforms, right? They're racing to cram in every conceivable tool.
Right, like dynamic context protocols, visual debuggers, complex routing.
Exactly. All of it shipped directly out of the box. But if you look at the stack of sources we're analyzing for you today, there is a super counterintuitive trend happening at the very top of the engineering field.
Yeah, a massive shift.
We've got these deep dives from three highly respected developers, and they've just completely abandoned those major platforms. They've migrated to this new open source AI agent framework called Pi.
Which is fascinating considering what Pi actually is.
Right. And the crazy thing is they didn't switch to Pi because it has more features. They switched because, well, it ships with absolutely nothing.
Yeah, it's a really radical departure from that maximalist software design we're all so used to seeing lately.
Literally a blank screen, basically.
Exactly. When you pull the Pi repository and spin it up, you're just staring at a blank terminal UI. There are no background subagents running, no, opinionated task planning algorithms dictating your workflow.
It's just bare bones.
So bare bones, it hands you exactly 4 raw capabilities. That's it.
Just four.
Yep. The ability to read a file, write a file, edit a file, and execute a bash command. That is the entire footprint out of the box.
Which, honestly begs the question, why are power users flocking to an empty shell?
Right. It sounds backward.
It does. Because if I'm integrating a state-of-the-art LLM into my dev environment, I want it to do the heavy lifting for me, right? Adopting a tool that makes me build the workflow from scratch, it feels like a massive regression.
Like you're going backward in time.
Yeah. I read that initial description in the sources, and my first thought was, this is like buying a brand new smartphone, taking it out of the box and realizing it only makes phone calls. Or, having to solder the motherboard yourself before you can even boot it up.
Yeah, I totally get that reaction. But the appeal makes a lot more sense when you actually look at the historical failure rate of AI abstraction layers over, like, the last couple of years.
Oh, because everything changes so fast?
Exactly. The underlying intelligence, the models from Anthropic, OpenAI, Meta, they're evolving at this just staggering pace.
Right.
So the way a model handles logic or tool calling or its context window today is fundamentally different than it was, say, 6 months ago.
Yeah, 6 months is a lifetime in AI right now.
It really is. So when you build this heavy, highly opinionated scaffolding, what developers call a harness around an AI model to make it useful, you're tightly coupling your entire workflow to a very specific generation of model behavior.
Oh, I see. So you fall into that trap of building to delete. Because one of our sources specifically called out frameworks like LangChain and Manus, right?
Yeah, those are the perfect examples.
LangChain has famously had to gut and rewrite its core architecture, I think it was 4 separate times.
4 times, yeah. And Manus has done it 5 times.
That is insane, just constantly rebuilding from scratch.
Well, they had to. They were trying to anticipate how developers would want to, chain prompts and manage memory.
Yeah.
And every time a new base model dropped with native parallel tool calling, or suddenly it has a massive context window.
The old way breaks.
Right. Their entire abstraction layer just became an anti-pattern literally overnight.
So Pi is basically engineered as a hedge against that volatility then.
Exactly the problem it's trying to solve.
Yeah.
By leveraging negative space and stripping that harness down to those 4 primitive functions, read, write, edit, execute, it strictly adheres to the open-closed principle.
Open-closed principle, meaning what exactly in this context?
It means the core engine is closed for modification, so it won't just break when a new LLM paradigm drops, but it's completely open for extension. It offloads all that workflow design entirely to you, the user.
The sources make a direct comparison here to Neovim, which I think contextualizes this perfectly for a lot of devs.
Oh, it's the perfect analogy.
Because Neovim isn't an IDE out of the box, right?
Yeah.
It's just a text editing engine. You don't just use Neovim. You spend, like, months building your own bespoke IDE on top of it.
Mapping every single keystroke.
Yeah, mapping everything to match the very specific quirks of your own brain and your own process. So Pi is essentially the Neovim of AI agents.
Precisely. You aren't forcing your development habits into this rigid interface designed by some product manager in Silicon Valley. You're molding the agent engine to mirror your local environment.
but I mean, that comparison inherently highlights a huge friction point, doesn't it?
The barrier to entry.
Yes. The barrier to entry for Neovim is notoriously brutal. You spend weeks debugging Lua configuration scripts just to get, like, a decent file explorer working.
Oh, it's a nightmare for beginners.
Right. So if Pi adopts that same bare-bones philosophy, it stands to reason that customizing it to match something like Cloud Code would be an absolute nightmare of TypeScript configuration.
And that is exactly where the architecture of Pi pulls off something genuinely remarkable.
This is the magic trick, right?
This is the magic trick. You don't actually write the configuration files to extend the agent.
The AI does it.
The AI writes them for you. This mechanism is probably, honestly, the most elegant piece of system design in the entire repository. It completely redefines the configuration loop.
Let's break down how that actually operates, because it's fascinating. From what the sources say, when you initialize Pi, sitting right there in the root directory is a file called extensions.md.
Right, just a standard markdown document.
Yeah, and this document contains the comprehensive documentation of Pi's own internal architecture, like how its tool schemas are structured, how it interfaces with the terminal UI, how it handles bash sub-processes.
It's the blueprint of itself.
Exactly. And the default system prompt just injects that markdown file directly into the agent's context window on boot.
So the AI is completely self-aware of the framework it's operating inside of.
It's just wild to think about. It creates this closed reflection loop.
Yeah, and because the LLM understands the API endpoints of its own harness, the configuration interface shifts from you writing code to you just writing natural language intents.
So it's literally like wishing for more wishes.
Kind of, yeah. If you want a specific weather widget rendered in your terminal dashboard alongside your code, you don't go parse the UI library yourself.
You just ask it.
You simply prompt the agent. You say, hey, build a weather widget for the UI. And the agent processes that intent, references the extensions.md file for the syntactic requirements, writes the TypeScript module, and saves it right into the local extensions directory.
Okay, I have to push back on the stability of that, though, because I use these models every day, and, they hallucinate. They drop brackets. They invent phantom dependencies. If I am asking an AI to actively rewrite the application layer that it is currently executing inside of, isn't that just a recipe for a catastrophic runtime crash?
It sounds incredibly risky, yeah.
It's like asking the engine to rebuild the chassis while the car is doing 80 on the highway.
That is a very real risk in standard agent architectures, I'll give you that. Because in most frameworks, state and memory are tightly bound to the runtime instance.
Right, so if it crashes, it's game over.
Exactly. If you inject a bad module, the process crashes, and you lose your entire context window when you have to restart the node. But Pi mitigates this through its hot reload architecture.
The /reload command.
Yes. The sources highlight this as the differentiator that actually makes this whole self-modification thing viable in the real world.
How does that actually work under the hood?
So the architecture deliberately decouples the terminal UI state from the execution environment. When the AI writes a new TypeScript extension to your local directory, you just type /reload into the terminal.
And it doesn't restart the whole app.
Nope. Pi does not restart the primary application process. It just dynamically unmounts the old tool schemas, flushes the module cache, and requires the newly generated files into the event loop.
Oh, wow. So your chat history is still there.
Your agent's memory context and your ongoing conversation history remain entirely uninterrupted.
So if the AI generates a broken widget, the TUI might throw a rendering error, right? But the cognitive loop of the agent is still completely alive.
Exactly. You just look at it and tell the agent, hey, that widget threw a type error on line 42, fix it and /reload.
You're literally pair programming with the agent to debug its own body.
That's a great way to put it. It turns a volatile generation process into an iterative, very low-stakes conversation. And because the friction of deploying these extensions is virtually zero, the dev community is pushing out these custom capabilities that you would never, ever see in a commercial closed-source platform.
Right, which perfectly transitions to what I want to talk about next. I want to look at what developers are actually building with this in the wild.
There are some wild examples in the sources.
Yeah, the real-world applications range from, like, simple workflow hacks to highly sophisticated architectural overrides. The most common entry-level extension mentioned in the sources is the /eat command.
A very fitting name for modern development cycles, honestly.
It really is. Because the standard process for deploying code involves so much context switching. You finish a feature, jump to the terminal, stage the files, run a git diff to remind yourself what you actually just changed, draft a commit message, push to the branch, and then navigate over to a browser to open a pull request.
It's a lot of steps, a
Yeah.
lot of friction.
It is. So a developer simply prompted Pi to consolidate all of that. Now they just type /yeet.
And it does everything.
Everything. The AI executes a bash subprocess to read the git diff, uses that diff to generate a semantically accurate commit message, stages it, pushes it, and triggers a PR via the GitHub CLI. One simple prompt replaces like 5 minutes of cognitive drag.
It's such a great example of chaining bash commands via an LLM intent. But the extensions that truly alter the economics of using AI agents, they operate much deeper in the stack.
Like what?
Well, there's an extension detailed in the sources called PyHypop, and this tackles a massive problem in agentic workflows, which is context degradation and token bloat.
Oh, right, because when an agent is debugging a repo, it frequently needs to read system states. It might run a git log or a tree command.
Yeah, and the problem is that bash outputs are entirely unoptimized for LLM consumption.
Right, a git log returns a massive payload. You get commit hashes, timestamps, author emails, verbose diffs. It's huge.
And every single character eats into your token limit. More importantly, it clogs the attention mechanism of the transformer model. If you flood the context window with raw bash output, the model's ability to actually follow instructions degrades rapidly.
So how does PyHypop fix that?
It acts as a middleware interceptor. It physically hooks into the bash execution pipeline. So when the agent fires a command, IPUP catches the raw output stream before it is returned to the LLM's context window.
It intercepts it.
Right. It parses that output sometimes via regex or sometimes by routing it through a much smaller localized model. And it strips out all the cryptographic hashes, the metadata, the formatting artifacts. It just returns the clean semantic payload back to the primary agent.
That's incredibly smart. The sources actually claim this specific interception can reduce token usage by up to 96% for heavy terminal commands.
96%. That is a massive reduction in compute costs.
And it's something you simply cannot do in a closed agent-like codex, right? Because you don't have access to the middleware layer to rewrite how bash outputs are parsed. You're just stuck with whatever they give you.
Exactly. It proves the value of that open-close principle we were discussing earlier. And, that exact same middleware philosophy is being leveraged for enterprise security, too.
Oh, right. The permission gate extension.
Yeah. The sources detail this permission gate, which is totally critical if you are deploying Pi in a team environment where it has access to sensitive databases.
I found the permission gate absolutely fascinating because security is traditionally the weakest link in LLM tools.
Oh, by far.
If you have an agent connected to a production database, you might try to put guardrails in the system prompt, like do not query the user salary table. But anyone familiar with prompt injection knows that an intern can easily trick the execution model into bypassing those system instructions.
Yeah, you simply cannot rely on the primary model to police itself. It just doesn't work.
Which is why the permission gate physically separates the authorization logic from the execution logic, right?
Yeah.
It introduces this really cool multi-model architecture.
Right. When a user submits a prompt, it doesn't go straight to the heavy execution model like Claude 3.5 Sonnet.
It gets intercepted again?
Exactly. The prompt is intercepted by a much smaller, faster routing model, something like Anthropic's Haiku. And this routing model evaluates the semantic intent of the prompt against a local permission.md policy file.
So it acts as an air gap.
Yeah.
The routing model doesn't even have access to the bash tools. It only has access to the policy file.
Yes. And if it determines the intent violates a security rule, it drops the request entirely and just returns a denial message to the UI. The heavy execution model, the one with the actual read and write access to your system, it never even sees the dangerous prompt.
It is literally a programmatic firewall built out of isolated AI logic.
It's brilliant.
There's also a secondary security extension mentioned in the sources called PyCloak. This one intercepts the standard output streams before they even render to the terminal UA.
Oh, right, for streamers.
Yeah, so if you're streaming your coding session live, PyCloak scans the stream for regex patterns matching, like API keys or environment variables, and it redacts them dynamically. It ensures that even if the agent pulls sensitive data into its context, it never flashes on your screen.
Which is a huge relief for anyone working in public.
Yeah.
But, introducing all these extensions, HiPop, Permission Gate, PyCloak, plus whatever custom bash tools you build, it does create a new architectural problem.
The bloat.
Right. Every time you add a tool to an agent, you have to inject that tool schema into the system prompt so the LLM actually knows how to use it.
Ah, So if I build out 50 custom tools, I am suddenly injecting thousands of tokens of JSON schema into the context window for every single interaction.
Exactly. That bloats the prompt and causes the exact same attention degradation that HiPop was designed to prevent in the first place. You're just trading bash bloat for schema bloat.
So how do they get around that?
Well, you're identifying the primary bottleneck of static tool loading there. Standard agents load their entire tool registry globally.
Right.
So if a web scraper tool is installed, its schema is injected into the context window, even if you're just asking the agent to, format a local Python script. But the Pi community solved this with an architectural pattern called the Ephemeral UI.
The ephemeral UI is such a cool concept.
It really is.
Instead of a global registry, heavy tools exist in an unmounted ephemeral state. They're basically just dormant scripts sitting in a background directory.
Yeah, exactly.
And if I know my current workflow requires interacting with a specific remote server, I explicitly prompt the agent to mount the server interaction tool just for this specific session. Pi dynamically injects that single schema into the active context.
And when you close the session, the tool is unmounted and the schema is flushed.
So the agent remains incredibly lean. The context window only contains the schemas required for the immediate intent.
Which maximizes the transformer's ability to focus on the actual logic. It's all about hyper-optimizing the cognitive load of the model.
It's incredible. But, we pull back and look at the broader implications here. The sources make it very clear that treating Pi as just a highly customizable coding assistant is honestly burying the lead.
Oh, absolutely. Goes way beyond that.
Yeah, what developers are actually doing is utilizing Pi as a modular foundational framework to build entirely new software applications. It shifts from being just an interface you interact with to being an engine you embed into other things.
Right, and to understand how that scaling actually works, we have to look at the package architecture. Because Pi isn't a monolith.
It's broken up.
Yeah, it's built using strict dependency injection, and it's split across 5 highly composable packages.
Right, it's a decoupled data pipeline.
Exactly. So first, you have the AI package. This abstracts all the messy business of API normalization. It handles the specific tokenizers, the streaming protocols, and the weird API quirks of OpenAI versus Anthropic versus Google, providing just one unified interface.
Just normalizes the inputs and outputs.
Yeah. Second, you have the agent package. This manages the actual cognitive loop, the state machine that handles plan and solve routines and React loops.
The core reasoning engine.
Yes. Third is the coding agent package. This layers the specific bash and file manipulation tools onto that core reasoning engine.
Got it.
Fourth is the TUI package, which is simply the terminal renderer for local interactions. And finally, you have the orchestrator package, which is engineered to manage concurrent sub-agent processes and handle inter-process communication.
And because these packages are completely decoupled, developers are literally ripping them apart to build wildly different products.
Yeah, the flexibility is insane.
For example, there is a popular project mentioned in the sources called OpenClaw. The developers of OpenClaw essentially just imported the AI and agent packages, and they completely discarded the terminal UI and coding packages.
Oh, right, they didn't need them.
Exactly. They wrapped that core reasoning engine in a proprietary set of web hosting and messaging integrations. They just use Pi as a headless intelligence routing system.
It's so smart. It allows them to bypass all the complexities of building a reliable agentic loop from scratch, and they can focus entirely on their specific business logic.
But the most extreme demonstration of this scalability in our sources, the one that really blew me away, is the project called Posteria.
Oh, Posteria is wild.
It pushes the concept of autonomous systems to its absolute limit. One of the developers utilized the Pi SDK to build a system designed not just to write code for a web app, but to independently orchestrate, launch, and operate an entire software business.
It is literally a fully autonomous corporate entity running locally on a machine.
Which sounds like science fiction. Posteria utilizes 11 distinct Pi subagents running concurrently. You have an agent assigned to market research, one assigned to front-end development, one managing the back-end database schema, another handling continuous integration testing, and so on.
And this is exactly where that fifth package, the orchestrator package, becomes completely critical.
I have to ask, though, how does that even function without collapsing? Because if one agent hallucinates a bad database migration and the front-end agent starts building UI components based on that hallucinated schema, a multi-agent system should theoretically enter this catastrophic failure spiral.
It usually does in early multi-agent systems, yeah.
Right. So how does the orchestrator manage state across 11 volatile models without it all blowing up?
It's because it operates on a shared memory graph rather than a master context window.
Oh, interesting.
Because if you try to force 11 agents to read and write to a single continuous prompt, the attention mechanism fails entirely. They just get confused. So instead, the orchestrator isolates their runtime environments.
No.
For example, the database agent executes its migration, it verifies the execution via its own isolated tool call, and then, and only then, it publishes the verified state change to a pub/sub event bus.
Oh, so it's an event-driven architecture.
Exactly. The front-end agent subscribes to that event bus. It only updates its internal context when it receives a validated state change from the database agent.
So the bad data never even reaches the other agents.
Right. By utilizing isolated validation loops and discrete messaging, the orchestrator prevents compounding hallucinations. The system scales reliably.
That is amazing.
You're taking the exact same framework that provides a 4-tool Neovim-style terminal app, and you deploy it to run an 11-node autonomous distributed system.
It really represents a fundamental paradigm shift in how developers are thinking about AI integration.
Definitely.
Whether you're a casual developer who is just tired of fighting with the bloated, opinionated defaults of a commercial IDE, or you're an enterprise architect designing a complex multi-agent pipeline, this framework forces you to rethink the relationship between the tool and the workflow.
You aren't forcing yourself into their box anymore.
Exactly. You are no longer adapting your environment to accommodate the limitations of a closed platform. You are providing the intelligence with the blueprints to construct an environment natively adapted to your specific logic.
It is a fascinating evolution of the whole open source ethos. I mean, we started this analysis looking at the concept of negative space in software architecture, right?
And the power of shipping nothing.
Exactly, how shipping an empty platform provides the durability needed to survive rapid iterations in underlying AI models. We explored the mechanics of self-modification, examining how a system can leverage its own documentation and hot reloading architecture to rewrite its capabilities without dropping context.
And we traced how that foundational flexibility scales from highly optimized local middleware, like PyHiPop, all the way to orchestrating autonomous corporate networks like Ghosteria.
It is a massive leap forward in tooling design.
It really is. And I think the broader trajectory here leaves us with a truly provocative final thought for you to consider as you navigate this space on your own. We are watching open source frameworks like Pi and Power Agent to dynamically rewrite their own source code, to redesign their own tooling interfaces, and to optimize their own memory consumption based entirely on the friction of their local environment.
Adapting on the fly.
Right. So at what point do we stop conceptualizing these systems as static software utilities that we just configure and start treating them as digital organisms that are actively adapting themselves to survive the constraints of their execution environment?
Something to think about.
Definitely. Thank you for joining us on this deep dive. Keep questioning the abstractions in your tech stack, keep exploring the negative space, and we'll catch you next time.